Okay, well, you might remember from a previous video where I was showing the 461 amplifier, and if we just zoom in a bit, you'll be able to see the amplifier here. Basically, this is 1 kilohertz to 150 megahertz, very flat amplifier, fixed gain 20 and 40. It's designed for instrumentation style work where you want to take a low-level signal, boost it up by a known value, and you can see that it takes a maximum of a 1 volt AC input signal and puts it out over here. It's a nice little unit. I've been planning to use it to work on a 415E SWR meter that been spending a ton of time trying to get running. I still haven't quite got that working yet. So anyway, I thought I'd put that aside, just let my mind clear, and come back to actually bringing this item back into spec. And if you remember from when we were reading this previously, I was looking at the gain calibration, and I'll put the video in so you can see the part of the measurement that I'm talking about. But basically, the gain calibration was not coming through exactly how it was supposed to. And so what they recommend that you do here is come in and replace, and let's just zoom in again so that we can see this a little better. This is the basic layout. You can see, and I showed you this in the other video, it's just basically a cascading set of emitter follower amplifiers. These guys in the middle do most of the amplification. The two on the ends basically handle impedance matching, and it's about 40 dB all the way through there, and then you switch in the attenuator to get the 20 dB. What I need to do is to come in here to manipulate the gain, is come in here and change R18, which is a factory selected value. And if we have a look at the factory selected values here, what you'll be able to see, and if I just bring that in here, is that there's a very small range of resistors that should enable me to change the gain and bring it up. And typically the value, as they say, is the value of that resistor is, I believe, sort of between 4.7 and 13 ohms. So let's go in and actually find that resistor and take it apart. So we'll zoom back out again so you can see what's going on. And I've been working on the 415E, so I haven't really been playing with the camera, because the issue that I had with the 415E is that I think that the amplifier, one of the amplifiers just simply aren't linear, and that's just been basically pretty boring stuff. But as I've been taking things into, basically changing values, testing things, seeing whether or not I can balance the values out. So let's come in here now, and we've got the bottom off the unit, and see if we can find R18. So if I bring up the little book here, what it's going to tell me, and you have to be a little careful with this. Oh, sorry. You have to be a little careful with this, because these older machines, these devices have often gone through substantial changes. And in fact, if we zoom in here, you can see what I mean. Here is the power layout for my particular 461. Here you can see what it's saying in the manual, where there's a bunch of different capacitors on the board, and I clearly don't have that on the board. So you sort of have to look in and make sure that the piece that you're actually going to replace matches what's here. And if we look in here, you can see that R18 is right next to C14 here and near Q4. So if we have a look in and see if we can find that, then we'll make that change. So that's the resistor, and you can see that the colors are that's a little sharper, the colors are very washed out. So I have no idea what that is, but I should be able to measure that in place. Let me see. Yeah, I think we'll be able to measure that in place. So let's grab a set of probes and just take a quick measurement and see what it actually is. That can't be right, because it's saying it's got to be because it's in circuit. It's saying that I'm getting anywhere from, it's bouncing right around. So I suspect that I am actually reading around on it. All right, well, let's see if we can. Hang on. Interesting. I did not notice this. If you have a look at the other side of the board, there is another resistor, and that resistor appears to be in parallel with R18. I wonder what somebody has done. Has R18 burnt out and then they've bodged in another resistor? I do not know. Let's see if we can get these guys out. Grab some solder wick. I've had good luck with the MG Chemicals solder wick. The one thing I do find that I have to do with all solder wick, regardless who it is to give it a solid. Give it a fluxing, just a run over with my flux pen. And so let's see if I can get that and melt that down and get that resistor out of there. There's an awful lot of solder going on in there. So, wow. Okay, let's keep taking that up. You can probably see the amount of solder that is coming up as I'm just pulling that along. That's a lot of solder. And that sort of explains it, because it's just basically laid down flat there across that. So hang on, let me just clear out that used piece of solder wick. Get my probes out of the road. So there has to have been something gone wrong with that resistor on the top that they put this guy in on as a sort of a workaround replacement. Let's see if I can get in here. And okay, so I can get most of that out here. Let's see if we can just clean up a bit of that. Wow, that's an awful lot of solder was in there. You can see the solder come up on the solder wick. So let's clip these guys in. And so I'm reading 23 ohms there. And so let's see if I can get this guy out here. Okay, and let's get my little Heiko FR330 in here. This thing here, if you haven't got one of these FR300s or an equivalent, you know, you really should put it on your Christmas list and think about it, because this has been, you know, with all my buggerizing around trying to get the 415 working, being able to nice solder job, being able to quickly take components into and out of circuits, Jesus, it's really made things a lot simpler. All right, well, let's measure that guy and see what was going on there. So let me grab the Kelvin clips and put that in. And so that's 9.98, and that was, the other guy was 23.33. So let's just plug that in. So it's going to 7 ohms. So I guess the guy didn't have a replacement. I guess he didn't have a replacement. You know, I guess he didn't have a replacement resistor, and so, you know, that was what was left over. You know, he had to try and come up with something. Given the size of those holes, I would have been tempted to actually bind the resistors together rather than doing that. Anyway, let me whack in a couple of bits of wire here, and this will give some distortion and so on, but what it'll enable me to do is to use my Decade box to run in the right amount of resistance, or at least to find the right amount of resistance, so that I can then put the right resistor in. Okay, so now I have the measures set up. We can see you've seen my 400F AC voltmeter in a previous video. This is an RCS 500 resistance capacitance substitution box, but we're just using the resistance part of it today. I really need to get the next one down, which gives me the 0.1 ohm, but that's substantially more money. Anyway, we got our meter zeroed, so let's turn the meter on. And now what I need to do is to plug the output of my signal generator into the AC voltmeter, and I need to set that to be minus 10 dB. So let me select that, come across to, and then we'll just scroll that in. I think that's pretty much bang on there. And what do they say? Let me actually check it says set for 0, on the minus 10 dB range. Okay, so now let's go back. There we go. Okay. So now we should be set. That's pretty much bang on there. So now the value that I calculated, remember when I measured the resistances, was about 6.3, 6.5, 6.7 ohms. So I've got 7 ohms written in there. And so let's take that out and let's drop in the output of the 450 and turn that on. And so now we can see that because the meter's way down here, where we don't have enough gain. Now, what it tells us is that we can change the value on here of A3R18 until the AC voltmeter does read minus 10 dB, plus or minus half a dB, and we should try and keep the resistance value between 4.7 and 13 ohms. So as we increase the amplitude, we decrease the resistance. So if I come in here and actually start scrolling that down, that's 6, that's 5, that's 4. And you know, we're about half a dB off. Let me I guess I may not have a great be something. Let's come back to 4. Yeah, I think we're somewhere between 3 and 4, and you can see that we've got 10 there. And in fact, you can see that the whole thing is a little bit capacitively coupled as my hand comes closer to it and so on. Yeah, wow. Okay, so that seems to be about the right value there. So now let's come in and step it up a range to see if the noise comes out of there. So let's swap these out again. Okay. Now I'm going to set that as 1. Let's come back here. Let's set that. Okay, that looks pretty good there. Okay, and so now I'm reading, I should be back and slightly, yeah, I think about 4 ohm there. And now that we've got a little bit more signal, it's less capacitively, the capacitive coupling is making less difference. Okay, I think that's good. Let's see if I can find a resistor of that value. Okay, so I've taken the decade box out of circuit there, and what I actually want to do now is to actually measure the exact resistance that I'm getting across there. So let's let me bring up my my DMM, and we'll set it to 4-wire mode. I'm reading 4.7, 4.8 ohms, and if we go have a look at the little table, that's at the bottom, but it's at the bottom and on the table. So I think you know, we could go in. It says that if you can't quite get it, right, if we look at the table, you know, you're not really supposed to go any lower than 4.7. But if we can't get it right, we can also modify A3 R29 in a like manner, which is further down the back of the, if we look at the schematic, where's R29? It's the next one over. So, we can modify that as well to bring up the gain effectively of it. But I think if I can find a 4.7 ohm resistor, actually it's gone up a little bit more. It's now, oh no, man, there's something screwy going on here. Now I'm reading 4.3 ohms, and that's pretty accurate. Alright, let me see if I can find something in that range, and then we'll see how we go. Let's give it a little bit more flux. Okay, and we'll give it some flux on the back here. I really like the MG Chemical flux too. I'm a bit of an MG Chemicals fanboy, actually. I have their flux cleaner and superwash and that sort of thing, and I've really been very happy with all of the stuff they have. So let's bend this in a little bit. I think these things look like quarter-watt. I think they look like quarter-watt resistors, so we should be okay with the quarter-watt resistor that I have here. If we're not, well, the smoke may escape a bit, but overall, I think we should be pretty good. Okay. So now let's give that a little bit of soldering. Make sure I don't melt the attenuator wire. Okay. We'll clean it up afterwards. Let's have a look. That came through reasonably well, I think. Okay. Let's let's get my side cutters out here. Just get these a quick. I like holding on to the piece of metal, the leg, so that when it goes somewhere I can always find it. Okay, let's set that up again and see how that goes. Okay, so I still have the stuff set up, my signal generator set up from the last time, so let's check this. Yep, we're still mid at neutral. Okay, let's plug this in. That's pretty much bang on 10. Let's plug this guy in now. This is our amplifier. And yeah, we're within half a dB there. Yep, I'm pretty happy with that. Let's see how it goes by resetting our amplitude level. Oh, cancel here. Amplitude. I'll go to 0 dB. No. And so let's bring that up. Let's just bring that up a little bit. Alright, so that's -5, and I'm reading 6 dB on my signal generator. So given the losses in the cables, You know, that's about right. But what I wanted to do was instead see if if I typed in 11 dB, do we jump straight to 0? We're about just inside half a dB. So I think, you know, I could have maybe gone, you know, a little lower on the resistor, but it's pretty close to being within spec. Actually, it's within spec because it's under it's under half a dB. All right. Well, that's just a short vid to show you that. I'm now going to go back and run it through its performance tests again and see how it all turns out. All right. Hope you enjoyed it. Catch you later. Bye.